Alright, today we'll be talking about triangle congruence, and we'll start off with some shortcuts, and the shortcuts are these bad boys right here. Okay? Alright, so normally congruent triangles are going to look like this. You're going to have your triangle all set up, it's going to be all nice and crisp and everything, and like I was saying last time, practice drawing the objects going the same direction, okay? Alright, and so let's say we have A, B, C, D, E, and F. Okay, so we would say triangle, let's take off the caps lock, it sounds like I'm yelling at you. Triangle ABC is congruent to triangle DEF. Okay, so that's a pretty good statement I can say right off the bat. So that means that angle A is equal to angle D, angle B is equal to angle E, angle, and this is stuff I need to prove and stuff. Angle C is equal to angle F. Okay, so those angles are all the same. Also, it means the side lengths are the same. So AB is equal to DE, or BC is equal to EF, and CA is equal to FD. Okay, so that's actually 6 things that I needed to know to say that triangles are congruent. So if I can check off this list of 6 things, I can say that these two triangles are congruent. And the symbol I would use is this right here. The keyboard shortcut for some reason is not working, so just feel free to just use is congruent in place of it and you should be fine. Okay, now that kind of sucks, is proving 6 things congruent. It's like, oh man, isn't there a shortcut? There is, and there's a shortcut by SSS and SAS. Okay, alright, now SSS is this, and it's SS congruency. Okay, if 3 sides of a triangle are congruent, to another triangle, then both are totally congruent. Okay? So that one just means that also the angles are congruent. Okay. Alright, now if you want to test this out, seriously, cut out some pieces of board, measure them, okay, and then try to construct 2 different triangles that have different angle measurements. So you would cut out 6 pieces of wood, each board matching one board from the other one. You could make it equilateral, you can do whatever. But if you try to mess with it and you try to do it, you'll find the angle to be the same every time. So SS congruency is you're seriously taking 3 fixed measurements and trying to manipulate them. So let's say we had these as fixed. No matter how I manipulate them, I'm going to have the same angles for both of them, okay, for both triangles. Okay, so as long as you realize that, SS congruency is really easy to work with. Okay, so technically all you need to know is this for this proof. And how would you do it? You would just prove 3 sides congruent. You would not even need to, you could skip these and just move on to the others. Okay, because they automatically are made congruent because of this proof right here. Okay? Alright, now we're going to talk about SAS. Okay, and SAS is this. Okay, so let's say we have 2 triangles. Okay, what's a shortcut for doing some of these triangles? Okay, SAS is if we know these two sides are congruent, and these are mirror images, and these two sides are congruent, and we know that the angle between them is also congruent, then we can also say that the rest is congruent. So this would be congruent to this, and that's SAS. So SAS congruency means that if two sides and an included angle are congruent in two triangles, then the totality of the two triangles are also congruent. Okay. The other side and two angles are congruent. Okay, that's what that one's saying. Okay, so in other words, if I can go ahead and say that those sides are congruent, then I can also say that these are congruent. Okay, by the SAS, these two are congruent, and these two as well. Okay, so I mean that's just really nice to know that you can actually use some shortcuts to do this instead of having to measure 6 different things. Okay, now once again, you do need to move it to the same, going the same direction. If you do that, your job's just going to be made a whole lot easier if you just work with it that way. Okay, now sometimes you'll be given a picture of a triangle and you might need to say, okay, what other information do I need to know that these two triangles are congruent? So let's take an example, something that looks like this. Okay, let's say that I knew that these two parts are congruent. What else do I need to know? Well, here, let's give it some letters. Here, let's go A, B, C, D. Okay, what else do I need to know? All right, well, I could either know angle D is equal to angle B for SAS congruency. Okay, so I can know those two because these are the two angles and this would be the included angle. Or I could say AC is equal to AC, because if you notice these are two triangles pushed together, for SSS congruency. Okay. All right, so I could say that this side. Now usually if, and I'm going to say this right now, usually if you have two triangles next to each other and they're attached at one side, then you can go ahead and say this is true. And this is usually, this reason right here is usually reflexive. Okay, because if you can use reflexive, it's going to help you use either SSS congruency or SAS congruency. But you can, you know, as you can see, I proved these two triangles two different ways with just two pieces of information. I could prove that they're both congruent by either SAS or SSS. And if you notice, there's two different measurements I'm dealing with. Okay. Now, do you have to be careful when you're working through this? Yes, but if you just sit there and you rotate the angles and you rotate the triangles until they go the same direction, or you take them apart and you rewrite them, it's going to make your job a whole lot easier. Okay. All right. Thank you very much, and that's it for congruent triangles by SSS and SAS.